Hey guys, so this is in place of our dry lab that was supposed to be this week for green chemistry. So if you've been looking ahead on your syllabus, you know that your green chemistry paper is coming. We'll talk a little bit about that today, but I want to give you a little bit of an update of what green chemistry is and how it affects what we do as organic chemists. There we go. All right, so green chemistry is not several things. It is not politics, it is not a public relations ploy, and it is not a pipe dream. It is actually a reality in what we're doing. You're going to see a couple examples of that today. What it's all about is innovation, new ideas, sustainability, and progress. It really is a different way of thinking about how chemistry can be done. This is not a um, thing we're just trying to see if it works. This is important in the sustainability of chemistry, the sustainability of the pharmaceutical industry, as well as the sustainability of our planet. As you know, there are 12 principles for green chemistry. They include preventing waste, atom economy, having less hazardous syntheses, designing benign chemicals for synthesis and for degradation, designing benign solvents and auxiliaries and using them, designing processes for energy efficiency, using renewable feedstocks, reducing derivatives, catalysis, designing products for degradation, real-time analysis for prevention of pollution, and using inherently benign chemistry. We'll talk about each of these as we go. So for example, the first one we're going to look at is prevention. So the principle behind this is that it is better to prevent waste than to clean it up after it's been created. That should make some intuitive sense. There are a couple of things we use to quantify this. E-factor is one of them. This was created by Roger Sheldon. And this relates the weight of the waste co-produced in your reaction to the weight of the product. We will do a lot of these calculations next semester in lab. Process mass intensity is very similar to E-factor, but it's used in the pharmaceutical industry. This expresses a ratio of the weights of all of the materials to the weight of the product. Atom economy says that synthetic methods should be designed to maximize the incorporation of all materials used in the process into the final product. So essentially, what atoms of the reactants are incorporated into the final product and which ones are wasted. There's a mathematical formula you can use to calculate this ratio. And again, you'll do that for me next semester in lab. Designing less hazardous syntheses tell us that wherever practical, these syntheses should be designed to use and get substances that possess little to no human health hazard to the environment, particularly related to toxicity. This one is easy to use as a get out of jail free card. As you know, hey, I'm designing a less hazardous synthesis, but it can actually be very difficult to apply. Designing safer chemicals says that chemical products should be designed to preserve the efficacy of function while reducing toxicity. So we still need to make ibuprofen, but it needs to be done in a less toxic manner. Safer solvents says that we should use safer solvents. Solvents actually contribute the most to toxicity most of the time because they are wasted the most. This also drives most of the energy consumption in a process. Speaking of energy, we should recognize energy requirements for their hazards and impacts. And we should minimize those if possible. So we really want to try to do things at ambient pressure and temperature. So not using a hot plate, not putting it under vacuum, things like that. We want to reduce the amount of heating, the amount of cooling, and the amount of separations that we have to do for a particular reaction. Renewable feedstocks says that we shouldn't use fossil fuels and we should be concerned about our carbon footprint. This includes things like electrical heating because those are powered by fossil fuels. Reducing derivatives looks like minimizing unnecessary derivatization. We'll do a lot more of talking about this kind of stuff next semester, but in most pharmaceutical processes, you have to protect a group on a molecule before you can do anything to it on another side, and then you can take that protecting group off. That creates a lot of waste. Catalysis is one we will spend a lot of time talking about. These are superior to stoichiometric reagents because they speed up the reaction, but don't get used up. You can reuse them and recover them. We should design chemical products for degradation so that at the end of their functional life, they break down into things like water or methane or CO2. Obviously, CO2 and methane, not the greatest things to break down into, but much less or much less problematic than some of the other molecules we could create. Real-time analysis for pollution prevention says that we should detect changes in things like pH, temperature, prior to the reaction going out of control. When pharmaceutical companies make things like ibuprofen or other drugs, they make them in huge vats. So think about when you spill something in lab, takes me a minute to clean it up. When you spill a vat of ibuprofen at a pharmaceutical company, it's going to take you a long time to clean it up. And so when a reaction like that goes out of control, it creates any sort of pressure buildup or any mess that comes out of the reactor. That's something you want to monitor in real time to try to reduce that possibility. We also want just inherently safer chemistry. This is a health and safety thing. We want to minimize the possibility of accidents. This is one of the reasons we don't use a whole lot of mercury thermometers anymore unless we have to. That's one of those things that we don't really want to have to clean up because of its hazards and its toxicity. So let's look at an example. This is the old process of making ibuprofen. As you can see, it has 6 steps going from that first isopropyl group on the benzene ring all the way around to a carboxylic acid and another methyl group on the opposite side of that ring. This particular process uses a number of stoichiometric reagents, including that AlCl3, that NaOCl2H5, the acid, the base in those next 2 steps. All of those are not super great green reaction steps, but they do get you the product that you want. You can also see in this first step, let me get my laser pointer here. You can also see in this first step that only half of this molecule is used in the final product. It's not even the final product at that point, but only half of it is used. So the other half is simply waste. And that would show up in some of the calculations that you would do for atom economy and E-factor and things like that. Here we create an epoxide. We then need an acid to open up that epoxide to create an aldehyde. We need a base to come in and do some nucleophilic substitution over here to create a nitrile, which is not part of our final molecule. And then we use some water to create our carboxylic acid here on the end. This process is 6 steps, creates a large amount of waste and byproducts. I believe the number that usually gets thrown around is about 12 tons of waste per batch. And we use a lot of stoichiometric reagents, and our atom efficiency, our atom economy is only 40%. There's a lot of waste in this process. And so the company that makes ibuprofen primarily said, hey, let's see if we can do it better. They found a way to do it better. And you'll notice that this process is only 3 steps long. The first reagent is the same, but uses a different stoichiometric reagent. And in this case, this is actually going to be a catalyst. There's also a Raney nickel catalyst used in the second step here, along with hydrogen, and then a palladium catalyst, as well as carbon monoxide, to get to the final step of ibuprofen. This process reduced the waste significantly and has much higher atom economy than the previous. So the higher your atom economy, the more atoms are used in your final product than were in your reactants. There's a small amount of unwanted byproducts and waste in this reaction, and it only took from the old process to the new process about 20 years for us to figure out that there was a better way to do this. The waste in this case got reduced significantly. So the first process was about 12 tons of waste. This one, I believe, is about 4 tons of waste per batch made. Okay, so that's an example of a reaction in which green chemistry was put into action. And that's the way ibuprofen is still made today in the 2020s. So what you're going to do for me for your green chemistry paper is you're going to find an example of someone who has put green chemistry into practice, and you are going to tell me about it. There's a few things that you need to do in order to do this, and you'll notice that these dates have changed a little bit from your original syllabus due to the fact that we've missed some class this week for the hurricane. Your principle and example of implementation is going to be due October 9th. These will all be due in Canvas. What I want you to do is pick one principle of the 12 and find a way someone has used it. You'll tell me about the principle in the introduction of your paper and why it's important to green chemistry. And then you will find the way that this has been implemented, and I'll show you an easy way to start looking for those here in just a minute. Your principle and example will be submitted by October 9th in Canvas, and I will approve each topic turned in and give you suggestions on how to move forward. Your rough draft will be due November 15th, your final draft on December 6th. Your paper needs to be 5 to 7 pages in length, not including figures and a reaction scheme. Your text should be double spaced, Times New Roman font 0.12, 1-inch margins on all sides, and you will turn it in an electronic format. I will check your work for plagiarism as well as for AI use. I am fine with you using AI to get ideas, maybe even to find a way that your principle has been implemented, but you are not allowed to use AI to write your paper for you. The more work you do on your rough draft, the more I can help you. So you've got about 3 weeks between your rough draft and your final to make some changes, but I will help you between your rough draft and your final. But if you only write me a page for your rough draft, it's not going to be super helpful for your final paper. You must include a reaction scheme for the example of implementation that you have chosen. For example, if I chose ibuprofen, which you are not allowed to do, that's the one you're not allowed to choose, I would show you the old mechanism of synthesis and the new mechanism of synthesis. For this semester, you do not need to show me mechanism arrows, but you do need to show me the reaction scheme. And what I mean by that is this is a reaction scheme. So thing 1, what you need, thing 2, and so on and so forth. Next semester, you will do reaction mechanisms with your green chemistry paper, but this semester you do not need to. The molecules that you have in your paper, though, need to be drawn by you. You cannot just copy and paste a reaction scheme from the internet or from a paper. You have to draw it yourself. And you will draw it in a program similar to or in ChemSketch, which I will show you how to download here in just a couple minutes. These should be included as figures at the end of or embedded into your paper. ChemSketch does not work well on Macs, so there is an alternate version that you can use on Macs, but we'll talk about that in just a second. When you have figures in your paper, you have to reference them in the text and label them with a caption below the figure. If you have a table, tables are also referenced in the text and labeled with captions above the table. Your conclusion of your paper should reflect the importance of the example you have chosen and the necessity of the principle of green chemistry that you have chosen as well. All of your references should be cited in an ACS format, and I will show you how to use a reference manager called Zotero that works really well with Word as well as Google Docs. You will never have to write another reference in your life as long as you use it well. Your paper has to reference at least 3 peer-reviewed journal articles, as well as any other number of sources from the internet, books, or otherwise. Okay, so here's my example on how to pick a topic. If you go to the EPA Green Chemistry Challenge Winners website, you can either follow this link or you can just search on Google Green Chemistry Challenge Winners EPA, and you'll find this website. Each year, the EPA announces winners for challenge awards. There's always an academic, a small business, a greener synthetic pathway, designing safer and degradable chemicals. And then I believe this one is new in the last few years, having a specific environmental benefit towards climate change. You can click into any of these. We'll take the academic category here from University of Delaware. and they'll tell you a little bit about it. So find one of these that's interesting to you, or you can use AI to try to find a different example. This list goes all the way back to the 1990s. There's 144 things you can choose from, so I guarantee you'll find something that's at least of some interest to you. There's things in this list from pharmaceuticals all the way to things like Roundup. Um, there's a lot that you can look at here. So this is the place I would start for your principle and implementation. Again, you are welcome to use AI to generate some different ideas, but this is the place that I would start if I were you. Once you've chosen your topic, you are going to need to just tell me a little bit about it. So when you, just go back here, once you pick your topic, when you choose or when you submit your pick principle and example, all I want you to do is give me a short paragraph on what it's about and why it seems interesting to you. And then you can go on to start working on your research. How do you do this research? Well, you're gonna need the library. This is not something you can do just on your own. You are going to need the library. So let me show you how to get references through interlibrary loan. I'm also going to suggest that you use Google Scholar, and I'm going to show you why here in a minute. So Milligan has access to lots of things, but not everything in terms of references. So let's say I picked, let's go with Merck's continuous process for Keytruda. So I will go into Google Scholar and search Keytruda green chemistry continuous process, and we'll see what we get. Let's see, this is a 2024 award, so this being done in 2021 doesn't really surprise me. Thank you, Google. There we go. So here I would get the abstract, but I cannot get the full text of this article. If this is one I wanted to choose to use, what I would want to do is take the title, go to the library's website, so library.milligan.edu, and search for it. My guess is we do not have access to this. It's gonna probably tell me here in just a second that I need to request it through interlibrary loan, which is not surprising to me. Yep. So this is the article I want. And if we do not have access to it, you need to request it via interlibrary loan. When you click this button, it's going to take you to the library's page that says, give me some information and I will help you get this paper. So what we do is we contract with other libraries and we say, hey, do you have access to this? My student needs it, and we share those resources. The nice thing about this is that it submits everything for you here. It usually takes 2 to 3 days to get an article back from interlibrary loan, but it really depends. So do not wait to get these articles that you need. Let's see if we can find one that we do have access to. If there is a link on Google Scholar for a PDF over here, we likely already have access to it. Because I'm on campus, it's going to give me some of what our library already has. So let's look here at this one. If I decided I wanted to use this, I could download the PDF. This looks like it's more of a PhD thesis. So this is going to be a very long article, but I do have access to it. I can save it on my computer. I can then edit it the whole, or not edit it, excuse me. I can read it. Yeah, this is a PhD thesis. It's 300 some pages, 284. This is probably not what I would want to use for my paper, but I do have access to it. All right. So that's how we get these articles. I am going to pull that one back up because I will use it here in just a second for showing you some management of references. So this was Zotero. Nope, this was Keytruda. There we go. All right, so that's how you use interlibrary loan. Again, if we have access to it, you will find it in our library. If not, you will have to get it through interlibrary loan. I would expect most of you to have to get at least one paper from interlibrary loan as you're working on this. All right, let's make sure I haven't missed anything yet. All right, so how to draw molecules. ChemSketch is the program that we use to draw molecules. And if you go to, I've lost my ChemSketch tab here. If you go to Google and type in ChemSketch, you will find this ACD Labs resources. This is a free chemical drawing software that was made for students. This is a version that only works well on PCs. So you do not need to purchase the full version of ChemSketch. All you need to do is download the freeware. You will have to put in your name, your academic institution, and so on and so forth, and then it will allow you to download the software. I already have it on my computer, so I am going to try to find it over here. So ChemSketch is a great program. I typically use ChemDraw to make the things that I put on your exams, just because it's one that I am a little bit more familiar with. But this is the free version of ChemDraw, essentially. Does all the same things. It's just a different name. So when you get into ChemSketch, you will see that it's going to give you a bunch of random things to click. But then you can start drawing molecules. So I will draw some pentane here. And if you go over to these molecules on the side, you can then put an oxygen here. So I just made 2-hydroxy pentane or 2-pentanol. Let's give it a nitrogen group as well. And you'll notice that this doesn't look very pretty. So this little tool up here, this lasso, you can get your whole molecule and you can clean the structure in tools, and that will make it look nice and pretty. When you are ready to copy this to your Word documents that you're working on for me, you're going to want to copy and paste it as a picture. So if I come into my I could do this in Word, I could do this in PowerPoint, I could do it wherever I want. I'm going to paste it as a picture because then I can make it big, I can make it small, I can do whatever I want to it. If you paste it in as a ChemSketch file, it's sometimes going to give you some weird formatting. In ChemSketch, you can do lots of things, and I'd encourage you to play around with it. You can do wedges, dashes, you can do arrows. So this would tell me, this is the next thing I would want to make. Erase some of this. Just want you. There we go. You can do all kinds of different arrows. We'll use this one. I don't know why the CH4s are still showing up. Those should be easy to get rid of at some point. I should be able to just do, well, all right. You get my point though. You can do curved arrows. You can do straight arrows. You can do all sorts of things. You can do any element that you want in ChemSketch. You just need to play around with it and see what it can do. You can also do things like benzene rings over here, as well as like tertiary butyl groups or phenyl carbonate groups, carboxylic acids already made for you. It's a pretty cool program that you can build whatever you'd like. So once you've learned how to build your molecules, and put them in your paper. I'm happy to help you with this as you work. But the last thing you need is a citation management software. So citation management softwares typically include you paying for them. And in previous years, I've used a software called EndNote. That one has now uh, abandoned its free version. So we are going to be working this year with the free version of Zotero. So if you go to zotero.org and there's a document on Canvas that will walk you through how to do this. You need to download Zotero 7. You can do this for Windows, or if you click this other versions, you can do it for Mac as well. You do want to install the Chrome connector here. This is going to be super helpful to make it really easy to input your citations when you are looking at them in Scholar or in another website. So I have Zotero open over here. This is what it looks like. I have several citations in here that I have put in today as I've been working on things, but I'm going to show you how to put in new citations in 3 different ways. So you can put in a citation using the DOI, PMID, or any other bib code number. So if you go to a paper, let's go to this one here. You should see somewhere in here a DOI number. It's right up here. If you copy that whole DOI number, I can actually get it to copy. There we go. Go back to Zotero, and this little guy right here, add items by identifier, you can paste in that DOI, click enter, and it will put in that entire reference for you without you having to do a thing, which is phenomenal. The other way to import them is to do them manually. So you can manually add using this new item button, a book or anything else. I will go in and add an article, a journal article. There we go, just so you can see how it looks. I'm just going to give it a bogus title. Mondays are the best. The author is Mudrack K. It's in the journal Jax. You could put in anything you know here, and then it will save in your library. I'm going to go ahead and delete this one just because it's bogus and I don't need it. I was just playing around. But that's another way you can add an article. The third way that you can do it is using that little the Zotero connector button that you can download for Chrome. The nice thing about this one is it will do websites as well as articles. So if I go back here to the article that we initially looked at for automated continuous synthesis and optimization, so it's for Keytruda, remember? If you go up here in Chrome to your extensions, make sure your Zotero connector is pinned or on. You can actually click this Zotero button. Okay, now it's going to be annoying. There we go. You're saving it to your library, and it would be in there if we go back to Zotero, Ready, Set, Flow. It actually came in twice. I would probably only do this with websites because that's what it looks like this is right now. If you have the paper, I would input it by the DOI number or another way there. But if you have a website you want to cite, that's a really great way to do it. So I'm going to, just so I don't get myself confused later, move that to the trash, and then I'll go find the DOI number for this one and input it. DOI. Where's the DOI number? Control find DOI. Apparently I'm blind. I can't find the DOI number today on this one. You can also click the cite button here. This is another way to do it. You could export the citation for the content listed below. You can export it. It'll go into your downloads, come back to Zotero. And then you can input the, I did this once today. I swear there's a way to do it. Import, there we go. This would be a Zotero file, likely, or it's gonna be a BibTeX file. I don't know which one. Find your downloads. It would be this first one. Probably gonna yell at me, but we'll see how well this works. There we go. One item was imported. And now it's showing up as a journal article. So pay attention to that as you're using the Zotero button up here. But let's say I wanted to cite the green chemistry page for the EPA for this particular one. I'd come up here again to the Zotero and it will save to my library. I can go back to Zotero and there it is, the Greener Synthetic Pathways Award. This is really, really helpful for organizing references. It's also really helpful for putting your references and your bibliography into your paper. So if I open a Word document, the nice thing about Zotero is that it works well with both Word and Google Docs. So you can use either one to write your paper as you so desire. I think Word has decided to not open. Ready to go. There it goes. All right. So when you're writing your paper, you are going to need to pay attention to the fact that once you have Zotero downloaded, you will see a little Zotero tab up here. Super helpful. You don't have to download anything else. It just shows up. So let's say I'm writing my paper here, and organic chemistry is awesome. And I have a reference for that. Just trust me on that. If you go over to Zotero, you can add or edit a citation. For this particular paper, for all papers you write for me, I want your citation to be in the American Chemical Society format, but you can use any format that there is, including MLA, APA, Chicago style, so you can use this for other classes as well. But again, ACS for me. Zotero is going to pop up here and say, where does this come from? So I'm going to search for something in the title of what I am citing. So I'm going to say it's this one, and then I'm just going to click enter, and it's going to input the citation with a number. Let's say that later on I decide I want to go back and put something before the sentence that I put in here. So Dr. M is the worst professor ever, and there is a citation to prove it. Okay, so let's say I have the citation to prove that. We will look for the ready, set, flow. Again, add edit citation. Zotero will pop up. I'm going to search for flow, and that's the Breen et al., I believe. I'm going to double check that that's the right paper. Is, but I'm going to double check that again. Yes, Breen et al. Is that paper. So I'll come back to Word and it inputted the citation for me. Let's refresh. Okay, it didn't like that for some reason. So let's redo that citation, add edit. It's because we didn't actually ever put it in. Oh boy, that's a fun citation. That doesn't look right, does it? All right, let's take that guy out. But it left the number 1 up here. So let's refresh this. I'm going to edit and add my bibliography in. And I did it in the middle of a sentence, which was dumb. Go ahead and re-add this one. This is a Green Chemistry Challenge Award. Don't love that both of those are number 1 right now. I'm still playing with Zotero and trying to figure out what it does and how well it does it. So it looks like we've got some difficulties in this one, but let's see if I can add a different citation here. Nope, I don't want green. I want there we go. Now it changed the numbers. Okay. So when you add in references in Zotero into Microsoft Word or into Google Docs, it should come up with a number, a superscript number here. And you always want it to go from 1 to how many ever references you have. You can, of course, reuse the number 1 and again, put it in as a citation here, but make sure that it always starts with 1. The best way to do that is usually just to refresh Zotero and it makes sure that everything is in the right order. So this would be my references at the end of my paper, but that's how Zotero works. It's so much easier than trying to write these by hand to keep track of which one is which and where it goes in the paper, because you can just link it just like this. All right, I think that's all I need to tell you at the moment. We did importing, putting it into Word, and making a bibliography. Again, Zotero does work with Google Docs as well. So pay attention to that. If you are working into Google Docs, it'll again just show up as a little Zotero tab, just like it does in Microsoft Word. If you have questions as you're working through any of this, please let me know. I'm happy to help. I'm also happy to help you download things and make sure they're working properly on your laptops. All right, I think that's all I've got for you now. So your job is to go find a principle and example that you want to study and make sure that that gets turned into me by October 9th. Looking forward to seeing you guys back in class.